Good morning, students. Your teacher here, Mr. Sarasinski. Another episode of Geometry. This is lesson 3-1. So we're skipping around a little bit, but the lessons that I'm providing you are lessons that were recommended to me by geometry teachers here. I have taught geometry one semester, and so I also think that these are some important lessons for you to get ahead of time. And then when you see them again, it'll just all start to click for you. So here we go. Today's lesson is parallel lines and transversals. Okay, so we're starting out with just some basic definitions. Parallel lines are two coplanar, meaning they exist on the same plane, lines that do not intersect. Arrows are used to indicate that lines are parallel. So, for example, here we have line AB and line CD. And to notate that those lines are parallel, we have, it's like an 11, basically, in between them. Okay? All right, parallel planes. These are, it's similar to lines, but they're planes that do not intersect. And we can just say plane J is parallel to plane K. Okay. Skew lines. So these are non-coplanar lines that do not intersect. And so in this shape, you can see like PS and VR. Okay, PS and VR. These are skew lines. They're not even going the same direction, but they'll never intersect because they're on different planes. TW and UQ. TW and UQ. And PT and QR. PT and QR. Okay, those are skew lines. All right, so here's a couple examples just based on these couple basic definitions that we have. Example 1, name all segments parallel to AE. Well, here's AE. Okay, so parallel would be BF. Okay, BF, DH, and GC, or CG. Okay, give two examples of parallel lines. Well, there's more than two. Oh, I'm sorry, parallel planes. So we have, erase some of this. We have plane EHF is parallel to plane, or EFG, however you want to do it, plane ABC. So plane, remember you need three letters to define a plane, or to name a plane. AD. Okay. And plane EFG. So that's the top and bottom. And there's more than two here. Okay, so we have the top and bottom, left and right, front and back. There are 6 sides to this shape. Okay, so we did the top and bottom. Now let's do this plane and this plane. So that would be plane ADE and plane BCF. Okay. Name all segments skew to GH. All right, so GH is here. So remember, skew lines are like going the opposite direction. So we can say FB. FB here. EA here. AD here. And BC here. Okay, so those are all my skew lines to GH. Number 2, name all segments parallel to JK. Here's JK. So parallel, we can say OP. And that's really it for this line segment. Name all segments parallel to NS. Okay, NS. Now this one's going to have several more. We can say JO, KP, LQ, and MR. Name a plane that is parallel to plane JKL. Okay, plane JKL is this end plane. So we can say plane OPQ. Okay, or PQR. You just need 3 letters to define it. Okay, name 4 segments skewed to RQ. Now the skews I feel like are a little trickier, just because they're a different direction, different positions, and different shapes. So RQ is here. So skew to RQ would be JO. Okay. JK. JN. And PK. Okay. Next page. All right, so we're going to learn about a couple new things, and you are going to use these a ton, okay? So get familiar with them quickly. The sooner you get familiar with them, the better off you're going to be. So we're going to be using these in this lesson and in the next lesson as well. And we're also going to be using these in proofs and some other things that you do. So, all right, a transversal is a line that intersects 2 or more lines. And an example is line T. Okay, line T intersects lines L and M. That is a transversal, okay? And when you have a transversal like this, it creates angle relationships, okay? Corresponding angles are angles on the same side of the transversal and in the same position. So that would be like angles 1 and 5. They're on the same side of the transversal in the same position. Angle 1 and angle 5. Angle 2 and angle 6. Angle 2 and angle 6. They're on the same side of the transversal in the same position. Angle 4 and angle 8. Okay. And angle 3 and angle 7. Okay. All right, alternate interior angles, just like they sound. So these are on the inside of our lines that are intersected. And so alternate interiors are like angle 4 and angle 6, and angle 3 and angle 5. Okay. Alternate exterior, so that'd be like 2 and 8. And angle 1 and angle 7. Consecutive interior are angles that are on the same side of the transversal on the inside. So that would be like angle 4 and angle 5 and angle 3 and angle 6. Okay, so here we have a couple examples where we just need to name what they are. Angles 1 and 8. These are alternate exterior angles. Okay, angle 2 and angle 3. Those are consecutive interior. Angles. Angle 5 and angle 7 are corresponding because they're on the same side in the same position. Angle 2 and angle 7, those are alternate interior angles. Angle 1 and angle 3, those are corresponding. They're on the same side in the same position. Okay. Angle 6 and angle 7, those are consecutive interior angles. Okay. All right, next example, angle 5 and angle 13, a little bigger here, okay? Don't be intimidated. Those are corresponding. Angle 7 and angle 14, alternate interior. Angle 3 and angle 6, alternate exterior. Angle 9 and angle 16, alternate exterior. Angle 4 and angle 7, consecutive interior. Angle 2 and angle 10, corresponding. Angle 8 and angle 14, consecutive interior. Angle 6 and angle 11, no relationship, okay? And the reason these are no relationship, so 6 and 11, okay, we're talking about these. They're on, if these are my two lines, and this is a transversal, then angle 6 is on a different transversal from angle 11, okay? And so if they're on different transversals, then they don't have any relationships, okay? They have to be on the same transversal to have a relationship. All right, letter I, 4 and 13, same situation. Different transversals, so they're no relationship. And then 4 and 9, that's alternate interior. Okay. These are some new angle relationships formed by transversals. I am your teacher. This is the way.